Okay, so everybody can see my desktop now, hopefully, and we'll go to the homework 1 file. So if you look at these two questions, they're talking about drawing a single card from the deck. I think that's where the confusion was. I want to talk about independence, but I'm talking about it in a slightly different way here. I'm talking about a single card. So you draw a single card and you're holding that single card in your hand, right? What question E was asking is there's two attributes of that card. One is the card red, and two is the card a heart. Are those two things independent of each other for that single card? I think some people thought maybe, although it says single card, that we would be drawing multiple cards. But in this case, we're actually drawing a single card from the deck. So think about it. First of all, what's the probability that a card is a heart in general? That probability is 1/4, right, or 25%. Now, if I know the card is red, does that change the probability that it's a heart? In other words, does the probability that it's a heart depend on whether or not it's red? And of course it does, right? So if I know the card is red, then the probability that it's a heart is 50%, right? If I know the card is not red, then the probability is 0%. So the point is that the probability that it is a heart changes based on whether or not it's red. Therefore, those two things are not independent for the single card, right? And now for F, same kind of thing. I've got a card in my hand. Event A is that I've got a black card. Event B is that I have a 3. Are those two probabilities independent? So think through those. The probability that I have a 3 is 1 out of 13, right? There are 52 cards in the deck. 4 of them are 3s. So the probability that it is a 3 is 1 out of 13. So now what if I know that it's black? Does that change the probability that it's a 3? It doesn't, right? So if I know that the card is black, there's still a 1 in 13 chance that the card's a 3, right? There are 26 black cards. 2 of them are 3s. Or in other words, it's still a 1 in 13. So those two events for that single card are independent. So that's what I wanted to get at there. So does the probability of one change based on the realization of the other? Right? And it doesn't in that case in E and F. So that's why E was those two events are not independent, where F was those two events are independent. Okay, so hopefully that clarifies that a little bit. That was the only one in the homework that I understand would have had any real significant questions. Okay, so let me go back to here. Okay, all right, so that was the first thing I wanted to mention. Other than that, it looks like everyone's kind of hitting these basic fundamentals of probability pretty effectively, which is good because we're going to continue to build on these basic concepts as we go through the semester. One other thing I thought might be fun to do today was do kind of a real-world example of probability. I know you guys are interested in that. So probability is an easy one because probability is everywhere in the real world, right? So whether we realize it or not, most business decisions involve some probabilistic thinking, whether it's investing decisions, plant expansion decisions, entering new markets. You're always, whether people are doing it consciously or not, they're assessing probabilities, assessing them accurately or otherwise, and making decisions based on probabilities. So I thought I was thinking about some good business examples where probabilistic thinking was particularly important, and I thought of one particular that I'd share with you. This is just kind of a fun example, nothing you need to worry about kind of making notes on or anything, but I just thought I'd mention cases where poor probabilistic thinking had quite drastically negative outcomes. So let me try to share my desktop again here. Okay, so hopefully this is still working, and I'm going to give you this little real-world example. Okay, so I borrowed this from Nate Silver. You might know who Nate Silver is, a well-known statistician, author. He likes to use this example when talking about the importance of probability, so I thought I'd use it as well. So I call this why thinking probabilistically is difficult and why it matters. Right? So it's not always easy to think probabilistically accurately, but why it can make a big difference. So let's talk about the context I want to talk about here. Many of you, especially if you're in banking, might be very familiar with this context, what happened with the financial crisis in the U.S. So let's think back first to before the financial crisis. So the context is we're in the United States pre-financial crisis, maybe 2005 and 2006. Some of you may know that a lot of people were making a lot of money trading mortgage-backed securities back then, or CDOs, what they were called, these collateralized debt obligations. And what these were, and so I apologize, some of you might be extremely familiar with these, But what they would do is package up mortgages. So take a number of mortgages, package them together, and then slice and dice that package in various ways into what are called tranches, right? So they might slice off a very risky part of those mortgages and allow investors with a high risk tolerance to buy that. Then they'd slice off a very low risk tranche and put that out there in the market as a very safe investment, because that portion of the mortgage basket was considered to be very safe. So some of you might be familiar with this that was going on quite extensively in the U.S. back pre-financial crisis. So I'll give you an example, just a simplified example of what a tranche might look like. So think about 6 mortgages. So we've packaged up 6 mortgages here. These are held by people all across the U.S. So mortgage 1 may be a lawyer in San Francisco. Mortgage 2 might be someone in Boston who is a plumber. Mortgage 3 may be a manager in Chicago. You get the idea. Just 6 mortgages from across the U.S. And we determined that the probability of each of these mortgages defaulting is just 5%. Right? So for each of these borrowers, there's a 95% chance they're going to pay back, or a 5% chance of default. So for this particular tranche, we've tried to make a very safe tranche, a safe way to bet on these mortgages. So if you buy this, you'll get paid except if all 6 borrowers default, right? So that seems pretty unlikely. So if only 4 of the borrowers default, you get paid. If only 5 of the 6 default on their mortgage, you still get paid. The only way you don't get paid is if all 6 borrowers default. So tranches like this were sliced apart and traded, right? So this would be potentially put out there as a quite safe investment, right? As long as everybody doesn't default, you're quite safe. So rating agencies like Moody's, for example, have to rate this. They have to, is this AAA? Is this the safest? Is this risky? So one thing they need to decide is, for this tranche, what's the probability that it doesn't pay off? Right, so what's the probability that this tranche doesn't pay off? And I can't see the chat right now, so since I'm sharing my desktop, I can't see chat also. So just think about that. What do you think the probability that it won't pay off is? One way to think about is this, right? So just to clarify, for this thing to fail, for this particular tranche not to pay, mortgage 1 has to default, and mortgage 2, and mortgage 3, and 4, and 5, and 6. So the guy out in California has to default. The plumber up in Boston also has to default on his mortgage. The manager in Chicago has to default. So everybody has to default. I say, all right, so I can see the chat. All right, so yeah, you have to think about how you're going to assess this probability. Here's one way to assess it. This is, in fact, it seems pretty unlikely, right? So if I'm just thinking through this, man, for all 6 of these borrowers to default all together, it seems pretty unlikely that I won't get paid. In fact, I can calculate the probability this way, right? They each have a 5% chance of defaulting, right? So there's a 5% chance that the person out in California defaults times 5% that mortgage 2 times 5% times 5%. So all 6 defaulting is going to be, this is only a little bit better than a 1 in a million chance, right? Extremely, extremely small chance that all 5 will default. All right, so that's one way to do it. If I'm a ratings agency, and this is not too far from what some ratings agencies actually did. So if I do this, I'll put it out there to investors and say, this is extremely safe. This particular tranche, very unlikely that it won't pay off. What assumption am I making here that's very, very important that allows me to multiply the probabilities like this? Think about that. I could do it, for example, with coin flips, right? So the probability of getting 6 heads in a row is 1/2 times 1/2 times 1/2 times 1/2, 6 times, right? I can multiply those probabilities of coin flips like that, because coin flips are what? What is the relationship between 2 coin flips? Does getting heads on the second flip depend on getting heads on the first flip? It doesn't, right? By multiplying these probabilities, I'm assuming that these events are independent, right? So again, what we just talked about in a different context here, I can only multiply them like this if the probability that the guy in California defaults has nothing to do with the probability that the guy in Boston defaults, etc. If these are all 6 completely independent events. Right, so someone just said something about it could hit everyone together, right? And that's kind of what ended up happening. I'm assuming independence here. And a lot of the ratings agencies, when they looked at these branches and came up with these probabilities, were assuming independence. And that's actually reasonable based on recent U.S. history. Right, so Moody's, for example, they were looking at home prices and mortgage activity back to 1980 in the U.S. And there hadn't been a situation where the entire market cratered together and was highly correlated. But that was flawed thinking. If they'd have looked, for example, at Japan, there was a fairly recent real estate crash there where many mortgages that you wouldn't think would be related, in fact, all crashed together. So what if I assume they're not independent? I can get very different results. So here is my probability of this investment not paying off if they're completely independent. What if they're perfectly correlated? That's the other extreme, right? So perfectly correlated means one of us defaults, we all default. So in that case, there's a 5% chance that they all default, right? So 5% that one goes and therefore they all go. That's a big, big difference, right? So investors are looking at this, thinking about this probability of default, which is very close to zero, right? This number right here, the first probability implies almost perfect safety. But what if in fact, and in reality they weren't perfectly correlated, it was somewhere in between, but there was a correlation. What if in fact it's not this probability of default, 0.000000156, but the probability of default is actually 5%, by the way, but the probability of default is actually 5%. That's 3.2 million times more likely, right? The difference between this number and this number is 3.2 million times as high as that, right? So again, this is an extreme example, but this is a good example of where oversimplified probabilistic thinking, someone didn't say, hold on, we're assuming independence here. Are we sure we're comfortable with the independence assumption? They just multiplied the probabilities out, came out with the idea, this is very, very safe, when in fact, the probability of default was much higher, because in a global economic crisis, the person defaulting in California, that is correlated to the person defaulting in Boston and Chicago, because the entire economy goes down together. So they all are correlated to some extent. And as someone mentioned in chat, that's happened in other economies. It hadn't happened recently in the U.S., and that's what that was the main driver of some of the rating agencies getting in trouble. So that's just a fun example of it makes a big difference, right? That actually took an entire economy into a tailspin, and many people would argue it was due in no small part to these mortgage obligations being considered to be much safer than they actually were. And that's all about getting the probabilities right. Okay? So anyway, just kind of a fun example to tie this to the real world. I thought you guys might enjoy. So let me just look through the comments. But yeah. Any questions or comments about that one? Hopefully that makes sense. Okay, so that's my kind of real world example of the week. We could, as I said, I think you guys have been using the office hours pretty effectively to go over questions that you have. Any questions about the week 2 material, I'd be happy to take. The course is really going to start ramping up. We're going to get into Excel much more heavily soon. So hopefully you'll enjoy and learn a lot over the next few weeks. Yeah, so please let the organizer know if you have any comments. As I said, get ready to learn a lot, and hopefully the course will be moving at a fast pace, but hopefully you'll keep up and get a lot of very applicable tools, especially as we get into the Excel portion of the less theoretical and the more hands-on Excel portion of the course. Absolutely. Right, so that comes with the textbook. That's a really neat tool. So the question is, do we have access to Analytics Solver platform? Definitely. When we get to that point in the course, out on Blackboard, there will be instructions on how you will get set up and get access to Analytics Solver platform. There's no additional charge. It comes with a book. So yes, we're going to be using, we're going to start with some Excel that doesn't use that premium product, but later in the course, we will be using Analytics Solver platform. I think you'll enjoy that. It's a way to really do a lot more than you can in basic Excel. Sure, yeah, so can you have it now? There's no reason not to. Maybe the instructions just haven't appeared on Blackboard yet, but I can work with Brenda and Karina to make sure that those instructions are visible, so that if you would like to do that, you can. So my preference is that you wait until we cover it as a class, because if you install it early, that might cause a little bit of confusion when we're doing the basic Excel. So I might have it appear on Blackboard with the caveat that my preference is you wait till we all install it together, but if you're just really interested in doing some examples on your own, you can do that now. So the chapter 4, I really just wanted you to read chapters 1 through 4. You don't need to work those examples, but again, if you would like the option to install Analytics Solver platform early, I'm not going to stop you. It comes with the textbook, so I'm happy to do that if you prefer. The problem will be when we start doing optimization models, I prefer to do it in base Excel without Analytics Solver installed, because there can be some conflicts if we're trying to do simple Excel models, but you already have Analytics Solver on there. But yeah, we can, Brenda, please remind me to talk to you about getting those instructions out there and visible to the students. Good question. Anything else? Okay, well, I know it's been a long day for a lot of you. I appreciate you guys logging in after a long day of work. And any other questions, please put a chat out there. Otherwise, you know where to find myself and Brenda. She's offering a lot of office hours. I'm available, and I'll plan on doing this next Thursday as well. All right, so the question is, how much, there's a tremendous amount of information in chapters 1 through 4. Are you going to be tested on it? Chapters 1 through 4 is more background information, so that's an important question. I'm not going to pull any questions directly from chapters 1 through 4, so you don't need to worry about memorizing all of the details in those chapters. Those are more for your review. Some of you will already know virtually everything in chapters 1 through 4. If you already have an analytical background, you can skim it. Those of you that it's unfamiliar, I want you to spend a little bit more time on it, but don't worry about it from a testing perspective. Worry about it more from a, you need to build that good foundation before we go into more advanced Excel. So good point. The actual test questions will come from the material that I cover personally in my own lectures, videos, etc. Chapters 1 through 4 reading is just kind of background to make sure that you're ready to hit the ground running when we get into Excel. Good question. Yeah, so I realize that's a lot of reading, but again, you can skim if it's familiar to you. I just think it's, before you dive into an analytical course, it's good to read that stuff in those first few chapters just to make sure that you're comfortable with some of the basics before we get into the more advanced material. Right, so I think we got this question last time as well, more examples. We are putting together a couple more examples for the probability topic, and we will continue. That's on the radar screen of myself and Brendan, if you guys want more practice problems. So we will continue to suggest additional practice problems for all the topics. All right, Excel versus Mac. Are we working the same way as in Excel for Windows? Analytics Solver platform is not compatible with Excel for Mac. So when we get into that, which will be rather quickly, you'll need to have Excel for Windows. That's explained in the syllabus as well. So you need to have Windows accessible in order to go through the Excel examples in the course. And I would go ahead and just get access to a Windows PC right from the start. So you're doing all the Excel in Excel for Windows. You can do that a couple ways. You can install Windows on your Mac. Some of you know how to do that. Partition your Mac and put Windows on there, or you might need to work out access to a Windows PC. But this is all in the syllabus as well about the importance of having access to a Windows PC. So thanks for bringing that up. That's something you're going to need to have for this course. All right, question about the homework. When it says more than one, that does not include one, right? So if I meant including one, I would have said greater than or equal to one. When I say more than one, I mean not including one, something more than one. Does not include the 1. That's correct. Okay, it looks like the questions are, that's all the questions we're getting tonight. So unless there's anything further, I'll sign off. Again, thanks for tuning in tonight to check in with me on the course. Please continue to give us feedback and questions. I know Brenda's very accessible and happy to help you with that. We will continue to give you more practice problems for those of you that are really wanting to dive in and do some extra work. We'll make sure that you have enough to keep you busy. And remember the homework due on Monday on probability distributions. And I will plan on seeing you guys at the same time next Thursday night. Okay? All right. Great, everybody. Have a good evening. See you next Thursday.